welcome to the first video, Module M1, where we're looking at all things to do with prime numbers. Let's start off with thinking, what numbers go into 18? Well, 1 must go into 18, and 1 goes into it 18 times. Now 2 must go into it because it's an even number. 2 goes into it 9 times, and 3 goes into 18, and that goes in 6 times. So those are the 6 numbers that go into 18, and they've got a special name, and they are called the factors of 18. Okay, so let's try another one. Let's try 20, and we'll do it in pairs like we did with 18. So 1 goes into 20, and the other part of the pair is 20. 2 goes into 20, and that goes in 10 times, and we could have 4 and 5. So those numbers, 1, 2, 4, 5, 10 and 20, are called the factors of 20. What about 21 then? Okay, well 1 must go into it, and that's 21 times. Now the only other pair is 3 and 7. So 1, 3, 7 and 21 are called the factors of 21. Okay, let's try another number. 5. What numbers go into 5? Well, 1 does, and that goes in 5 times, but that's it. Now if a number has only 2 factors, then it is called a prime number, if it's only got 2 factors. So 5 is a prime number. Okay, what about 13? What numbers go into it? Well, 1 and 13. And we know the name of this now. If a number's only got 2 factors, it's called a prime number. And 13 is a prime number. What about 1? What numbers go into 1? Bit of a trick question really, isn't it? 1 goes into 1, and that's it. Now 1 does not have 2 factors, so because it hasn't got 2 factors, it's not a prime number. So remember that, 1 is not a prime number. Little exercise for you to do now. What you've got to do is find the prime numbers in those first 40 numbers. So what you need to do, get a bit of paper and a pen, jot them down, press pause now and play when you want to find the answer. Okay, let's have a look. So we know 1 isn't a prime number, 2 is, and 2 is the only even prime number. No other even number is a prime number. 3 is a prime number, so we can miss out 4. 5 is a prime number, we can miss out 6. 7 is a prime number, we can miss out 8. Now 9 is not a prime number because the factors of 9 are 1, 3 and 9. 11 is a prime number, then we got 13. 15 isn't a prime number, and any number ending in 5, apart from 5, is not a prime number. 16 isn't, 17 is a prime number, 19. 21 isn't, 3 7s are 21. 23 is a prime number. 25 isn't a prime number, it's got factors 1, 5 and 25. 27 has got factors 1, 3, 9, 27, but 29 is prime. Any more? Did you get 31? 33 isn't, 35 isn't, 37 is, and 39, no, 39 isn't, because its factors are 3, 19, and 1 and 39. So there we go. There's the prime numbers in the first 40 numbers. So let's have a look back to the factors of 18. Which one of these numbers then are prime numbers? Well, 2 is a prime number, and 3 is. No, 6, 9 and 18 and 1 are not. So 2 and 3 have got a special name, and they are called the prime factors of 18. Okay, so let's have a look at 21. Are there any prime numbers in that list of factors? Well, we know 3 is a prime number, 7 is a prime number, and so 3 and 7 are called the prime factors of 21. Excellent. So the next little bit we're going to look at, what numbers are there in the 5 times table? Well, 1 times 5 is 5, 2 times 5 is 10, etc., etc. Now these numbers, 5, 10, 15, 20, etc., they are called the multiples of 5. And the list goes on forever. Okay? So 5, 10, 15, 20 are the multiples of 5. So what are the first 8 multiples of 3? Well, let's have a think then. 1 3 is 3, 2 3s are 6, 3 3s are 9, all the way up to 8 3s are 24. So the first 8 multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24. Let's do one more then. What are the first 5 multiples of 9? Let's think of the 9 times table. 1 times 9 is 9, 2 times 9, 18, etc. So the first 5 multiples of 9 are 9, 18, 27, 36, and 45. Okay, so let's move on now. We're going to have another look at prime factors and the product of prime factors. Now, what product means is what you get when you multiply. Okay, so think of product as multiplying. Now, there's the number 30. Now, we want two numbers, but we can't use one, okay? Two numbers that we can multiply to get 30. Okay, we'll have, well, 3 and 10. 3 tens are 30. Now, were either of those prime numbers? Yeah, 3 is a prime number. So we put a little shape around it. Now, you're not going to have to draw that exotic shape there. You can just do a circle. You can do the shape if you want, but it would take a long time, wouldn't it? Now, what about 10? What two numbers could we have? Remember, we can't use 1 to get 10. We could use 2 times 5. Now, were either those or both of them prime? They are both prime numbers. Now, when we've got no more numbers, other than the prime numbers with shapes around them, or circles you'll be drawing, we stop. And we say, okay, 30 is, and we put these in numerical order. We'll have 2 first, times 3, times 5. There we go. That is 30 expressed as a product of prime factors. Now, it doesn't matter if we start with 3 and 10. We could start with, say, what, 5 sixes. 5 times 6 is 30. Are either of those prime? 5 is a prime number. Now, what two numbers, remember we can't use 1, do we use to multiply to get 6? We're going to use 2 times 3. Are they prime? Yep. So round goes the shape. And so 30 is, and we'll put them in order, 2 times 3 times 5. Let's try another one. 84 as a product of prime factors in index form. So we've got an extra little bit on the end this time. Let's not worry too much about the index form for the minute. Let's get 84. Now, what can we multiply then to get 84? Two numbers. What about 2 times 42? Yep, that's 84. Any primes there? Yep, 2. Okay, what two numbers can we multiply to get 42? 6 times 7. We could have used 2 times 21 if we wanted as well, couldn't we? But I've chosen 6 times 7. Any prime numbers there? Yep, 7. What two numbers do we use to multiply to get 6? Well, that's going to be 2 times 3. Primes? Yep, we'll put that round there. So 84, now let's put them in numerical order. It's 2, times 2 again, times 3, times 7. But remember, at the top of the page it says product of prime factors in index form. So index form means using a power. So 2 times 2, we've come across that many times before. 2 times 2 can be written as 2 squared. 2 with a power of 2 up there like that. So 84 is 2 times 2 times 3 times 7, but in index form, 2 squared times 3 times 7. Alright, let's try another one. 300. Right, what can we multiply to get 300? Well, the most obvious one might be 3 and 100, but I've chosen 30 times 10. I often choose 10 if anything ends in 0. Any prime numbers there? No, they're not prime, are they? Okay, so let's have a look. What two numbers could I have to multiply to get 30? Well, I'm going to use 3 and 10. Any prime numbers? Yeah, 3. Good. What about 10? Well, 10, remember we can't use 1, so that's going to have to be 2 times 5. Any prime numbers? Yep, 2 and 5. So we're left with 10. Oh, we know what 10 is, isn't it? 10 is 2 times 5. Any prime numbers? There we go. So 300 equals, let's write them in numerical order, 2 times 2 times 3 times 5 times 5. But remember, we've got to give our answer in index form. 2 times 2, well, that's 2 squared, and 5 times 5 is 5 squared. So there we go. 300 as a product of prime factors in index form is 2 squared times 3 times 5 squared. Let's try a big number then, an awkward number. 770. Alright, well, it ends in a 0, so that means 10 must go into it, so 77 times 10. Any prime numbers there? No. Okay, let's try 77. What can we multiply to get 77? Oh, 7 times 11. Any prime numbers? Yeah, both of them. And 10, well, we had that just now, and it made 2 times 5, so there we go. They're prime. So we finished. So 770 looked like it could be complicated, but actually it's quite straightforward. And it's 2 times 5 times 7 times 11. So that's one way of finding the product of prime factors. There is another way of doing this. Now you might prefer this way. Let's have a look. This is called the ladder method. So express 28 as a product of prime factors. We start off with 28 there, and we do a little ladder, or the first rung of it like that. Now we need to know the prime numbers, and we start with the smallest one. So what goes into 28? The smallest prime number is 2. Does 2 go into 28? Yeah, 14 times. Right. Is there a prime number that we know goes into 14? Oh, it's an even number, yeah, so 2 goes into 14. How many times? 7 times. Now 2 doesn't go into 7. The next prime number is 3. Now that doesn't go into 7. 5, no. Next prime number is 7. Now 7 goes into 7 one time. And we stop when we're left with a 1 like that. So 28 is 2 times 2 times 7. Reading those numbers from the left hand side of the ladder. And remember, it's got to be an index form. So 2 times 2, 2 squared times 7. Excellent. Let's try 72 then, using the ladder method. It's an even number, so 2 must go into it. 2 into 7 is 3, 1 left over, 2 into 12 is 6, so 2 goes into 72 36 times. Another even number, so we know 2 will go into that. 2 into 36, 18 times. Another even number, 2 into 18, 9 times. 2 doesn't go into 9, let's try 3. How many 3's in 9? Yeah, 3 does go into 9, and it goes 3 times. And we know what number goes into 3. Well, that's got to be 3. How many 3's in 3? 1. When we get to 1, we stop our ladder. And we say 72 is 2 times 2 times 2 times 3 times 3. Now 2 times 2 times 2 is 2 to the power 3, or 2 cubed. 3 times 3 is 3 squared. There we have it in index form. Now I always started with 2 and went on to 3 and went on to 5. It doesn't actually matter which order we do it in. So let's try 450 using our ladder method. Now we're thinking of a prime number that goes into 450. Well, 5. How many 5's in 450? Well, 5's into 45 is 9, and there's a 0 on the end. So what prime number goes into 90? Well, I know 3 goes into 90. 3 goes in 30 times. What prime number goes into 30? Well, 2. It's an even number. And 2 goes in 15 times. What prime number goes into 15? 3 goes into 15 5 times. What prime number goes into 5? Well, it's just 5. How many 5's in 5? 1. There we go. So what we've got is that 450 is 5 times 3 times 2 times 3 times 5, but we tend to write them in order. So we'll put that in order as 2 times 3 times 3 times 5 times 5, but we've got to put them in index form as well. So 3 times 3 is 3 squared, 5 times 5 is 5 squared. Okay, so lots of people really like that ladder method and prefer it. I prefer the other way, but you should use the way you're most comfortable with. Okay, let's finish off with you having a go at one. Can you express 132 as a product of prime factor index form? Okay, so press pause, and when you want the answer, press play. Okay, let's have a look. Now, this is the method I prefer. So I started off with 2 in 66. You might have different numbers here, but your product of prime factors will be the same when we get to the bottom. 2 is a prime number, so I'll put a little circle around that. Now 66, oh, that could be 6 11s. Any prime numbers there? Yeah, 11 is a prime number. And what about 6? Well, 6 is 2 times 3. And they're both prime. So 132 is 2 times 2 times 3 times 11, which in index form, 2 squared times 3 times 11. So there we go. We know about prime numbers, prime factors, we know about multiples, and we know about product of prime factor in index form. Well done. That's the end of the first one. It's bye from me, and I'll speak to you in the next one when we look at square numbers. Bye for now.